So under similarity based approach, we have one of the technique that is thresholding. We just now discussed it, and now we are going for second approach, which is region based segmentation. Okay. So in certain cases, edges discontinuity based approach, that is determining the edges, then linking them, determining the boundaries, and using those boundaries we can segment the image. Or in thresholding, we can simply compare every pixel value with the threshold and we can segment it into background and object. But in certain cases, these two approaches, they are not useful. They don't give us correct segmentation. In such case, we can go for one better approach, which is known as region-based segmentation. So region-based segmentation is based on the connectivity of similar pixels in a region. So in this case, there is one assumption that each region is uniform in nature and connectivity of the pixels within the region is very important. Okay, so under region-based segmentation, there are main two approaches, region growing and region splitting. So in case of region growing technique, we start with a set of seed points or seed pixels, okay? And then we start growing the region around the seed pixel. So we check every neighbor of the seed pixel, whether it is similar to the seed pixel. If it is similar to the seed pixel, we can merge it into that region, or we can label them with the same label. And when the pixel is not similar, we label it with some other label. Now, once we get the neighbors which are similar, we repeat the process for each and every neighboring pixel which is similar to the seed pixel. So similarity criteria can be any, like we can check for same gray value, or we can check for gray values which are within certain range. Okay. So segmentation is the way to separate the image into simple regions with homogeneous behavior. Okay. So the regions having similarity, they are known as homogeneous region. Okay. So one of the simplest approach among region-based methods is region growing technique. So we select a seed point as shown here. Say this orange pixel is seed point. Then we check all its neighbors. If we are connecting 4 neighborhoods, we check only 2 vertical, 2 horizontal neighbors. When we are considering 8 neighborhoods, we check all the 8 neighbors. So we select the seed point, or we can have multiple seed points, and we apply this algorithm for each and every seed point. Then we define a growth criteria or similarity criteria. Then we join all pixels which are connected to the seed point, and we follow the growth criteria. If the pixels are similar, we connect them to the seed pixel, and then we continue this process for each and every neighboring pixel which is similar to the seed pixel. And then we stop this process when no other pixels are similar to each other. So we follow these 4 steps for first seed point. Then say we have a seed point, one more seed point here, and one more seed point here. Then we repeat all these 4 steps for all these seed points, and we can get different regions. Okay. So this is region growing algorithm. So here region growing algorithm, we or for region based techniques, we use some properties. So capital R represents the entire image region. So segmentation is a process that partitions R into sub-regions, say R1, R2 up to Rn. and union of all these regions is your R, that is entire image. Entire image is denoted as R, and union of all these regions, union Ri, where I runs from 1 to n, it represents your original image R. Okay. So every Ri or every sub-region R1, R2, Rn is a connected region. Okay. Now, if we take intersection of two regions, R1 intersection R2, it should be a null set. For I not equal to J, it should be a null set. Okay. Then predicate Ri should be equal to true. So for all the points in the given region, they should satisfy some predefined property, predicate or similarity criteria. Okay. Then predicate Ri union Rj should be false. So for any adjacent regions, Ri and Rj, your predicate should be different. Okay. So PRK is a logical predicate defined over the points in set Rk. So for example, PRK is equal to true if all pixels in Rk have the same gray level. This is one example of the predicate or similarity criteria. Okay, so all these rules or properties of region growing techniques, are these clear to you? Did you get all these properties, their notations, and what is their meaning? Is it clear? If clear, we can proceed. Please type yes or no. If these properties are clear, so if these properties are clear, you can use this region growing algorithm to segment the image. So in region growing, as understood by the algorithm, first we pick up an arbitrary pixel as seed, then we examine the nearest neighbors. A neighboring pixel is accepted to belong to the same region if they satisfy the homogeneity property of the region or similarity criteria of the region. Then currently added pixels are considered now as new seed pixels, and process is repeated until no more pixel is added. Okay. So all the pixel of current region are marked with a unique label. Then another seed is selected from remaining region, and above process is repeated until every pixel in the image is assigned to some region. Okay, so this is region growing process. Now there are some drawbacks of this method. See, if your regions are very large, then in terms of execution time, this region growing technique will take a long time. Then how to select homogeneity property or similarity criteria, that is another issue with region growing. And where to select the seed, that is also third issue. So we should select appropriate location of the seed pixel so that less amount of time is needed. Then we should use proper homogeneity property so that the image is divided into appropriate number of regions or required regions. And if region size is very large, it needs large amount of time for execution. So instead of this region growing technique, we can go for some other technique. So before that, just have a look at one example of region growing. So say this is your input image, okay? And in this input image, we can apply this region growing technique. We can start by selecting seeds from different locations. So initially we can select a seed here, then we can get this particular region. Then from remaining area, we can select seeds at different locations, okay? Or say we select one more seed here, then we complete this particular region, okay? Then from the remaining region, again we select one particular seed, we complete the region growing. Then we select one more seed here, we get this region. Then we select one more seed here and then we get this region. And after this, we understand that every pixel is assigned to one particular region and we can stop the process. Okay. And in the end, we can get this particular segmentation. Okay. So this is another example of segmentation process by using region growing technique. So uh, with this, I hope all of you have understood region growing technique and what are its limitations. Okay. So here there is one more example of region growing technique. So by using say 3 different seeds, we have this image which is segmented in 3 regions and every region is labeled by one label. So here label is 1, here label is 2 and here label is 3. Now after segmenting the image, in order to provide compression, we can apply run length coding for every row. So here there are 5 consecutive ones and 5 consecutive twos. So we can code them as 1, 5, 2, 5. Then we go for next row. In next row there are 6 consecutive ones. So 1, 6 and 4, 2 consecutive 4s, 2, 4 and so on. So we can apply this run length coding for every row. For last row, there are 5 consecutive 3s. So it is coded as 3, 5. Then there are 5 consecutive 2s, so 2, 5. So after this coding, instead of these total 100 values, this is 10 by 10 image. So there are 100 values. Those are reduced to only 40 values because of run length encoding. So here we can compress the image by applying run length encoding row by row. Instead of row by row, we can also apply run length coding column by column. So by column, we are getting these values. So along these few rows, there are many changes, 1, 2, 1, 3. So the length is greater and total we are getting 52 values. So instead of column by column compression, we can go for row by row compression. So in this example, row by row compression was able to represent the region with fewer values as compared to column by column compression. So this is one example how we can segment the image and we can further compress it by RAT and then we can store the image with these compressed values. Okay, compressed tokens, that is here we need only 40 tokens. Okay. So here there is example, segment the following image using region growing algorithm based on 8 connected pixels and write down all the steps. So these steps are nothing but your region growing algorithm. So here 1, 2, 3, 4, 5. 5 pixels are given as seed pixels. Then homogeneity criteria used is you should have same gray value. So we can start with this pixel. We can check for neighboring pixels. Okay, if they are having same value, we label them in one group. Okay, then we start with the second seed. We check the pixels. Then for these neighboring pixels have same value. These pixels they don't have same value. So these are in the same group. Then we go to next pixel. We repeat the algorithm. Again, we get these 3 neighbors. Then we go to next pixel. Okay, there was temporary loss of network. So I could so I'm repeating the point. Okay, just tell me whether the screen is visible to you. Kindly let me know. Is the screen visible to you? Is the screen visible? Please.
Ma'am, it's loading. Now it's visible.
It's visible. Okay. Thank you. Okay, so this is an example of region growing. So here 5 different seed points are given. Okay, and we can start with each seed and we can check whether the neighboring pixels have same value. If they have same value, we group them into same region. Then we go to next neighbor, check the values and repeat the process for each and every pixel. And after that, we will get this particular region as one region. Okay. Then we go to the next seed point, that is this point, and again we can compare all the neighbors. So here these 3 are not connected, but these other remaining 5 pixels are connected. So we group them in the same group. Then we move to next, again check the neighbor. Then we move to next, again check the neighbor, and we continue this process until no more pixel is similar to this pixel. So we can get this particular region as single region. Then we start with this particular seed and we continue the process of checking the pixel and putting it into the same group, and we will get this particular region. Then we move to next seed and again check the regions, check the pixels, whether they are similar to this, and we repeat the process many times and we get this region, and in the end we will start with this last seed and we can get all these pixels which are similar, having similar gray value. Okay, so this is how we can use region growing technique. Okay, so after segmentation, so this is one more example. So in this pixel, this is a welding, defective welding image, and at these points, the weld is defective. Okay, so here we can apply region growing and check the we check the various pixels starting with some seed point. So here, first we plot the histogram. So from the histogram, there are many bright values, and this bright region actually represents the defect in the wave. Okay, but here, if we look at the histogram, there is overlapping. So with thresholding technique, we cannot detect it properly. So we can go for region growing technique. So we can select all the very bright pixels as seed pixels. Okay, so here, say these are the bright pixels with value 255. So from this image, we select the pixels having value 255 and we use them, all these pixels as seed pixels. And for every seed pixel, we apply region growing technique. And here we use similarity criteria as all the pixels having value which is, say, which is ranging from 190 to 255. So if you look at this histogram, all the pixels in the range 191 to 255, they represent this portion which is defective welding. So we select the criteria that we check the neighboring pixels. If they are in the range 191 to 255, we add them to the same group. So as shown here, we start with every seed pixel, and if the pixel is in the range 191 to 255, by using 8 connectivity, we add that to the seed pixel in the same region. And we continue this process until all the seed pixels are covered and all the similar neighbors are grouped into the same group. Okay, so after this applying region growing, we get these white regions which indicate the defective weld, and then we put these regions on the original image and we apply them some border to differentiate it from other background. Okay, So these are the defective welded regions in the given image. So this is an application of region growing for detecting the welded parts for defect. Okay. Okay, so let me check what is the time. Okay, then as there is one drawback of region growing technique that it takes lots of time if your region is very large. So another approach which is useful for large regions is region splitting. So the opposite approach to region growing is region splitting. In case of region growing, we start with a single pixel, which is seed pixel, and we keep on growing the region by adding neighbors which are similar to the seed. We add them to the same region, and then we keep on growing the region. Okay. So in region splitting, it is exactly reverse approach. Here, this is a top-down approach. We start with the assumption that your entire image is homogeneous. Okay. So we start with the image, and if the image is not homogeneous, we split it into multiple portions, either 2 portions or 4 portions. So we split it into 2 regions. Then again we check the 2 regions. If they are homogeneous, we keep it as it is. If they are not homogeneous, we divide them into further 2 regions. And we check it for each and every region. And we continue the process until we get homogeneous regions or uniform regions. Okay. So this splitting procedure is repeated recursively until we split the image into homogeneous regions. Okay, so again in the region splitting technique, how to split the image is a question. So usually we use approach that is quad tree approach. So for every iteration, we divide the image into 4 equal regions. So we assume original image as square image, and we keep on splitting it into 4 regions. So this is your original image. After first split, we get 4 regions, R1, R2, R3 and R4. Okay. Then let us say we find R1 is homogeneous, R2 is homogeneous, R3 is homogeneous, and R4 is not homogeneous. So we split it further into 4 regions, R41, R42, R43 and R44. So here we get one more branch to the tree. Then we check again homogeneity for R41, 42, 43, 44. Now say your R41 is homogeneous, R43 is homogeneous, R44 is homogeneous, but R42 is not homogeneous. So we split it further into 4 regions. So we can split it further into 4 equal regions. Okay, and we get 4 nodes. We can name them as R421, R421. Then next will be R422, R422. Third region will be R423, and fourth region will be R424. Okay, and we can continue the process. So this is region splitting technique. Okay, so as shown here, say this is your input image. By region splitting, first we observe that the image is not homogeneous. So we split it into 4 regions, R0, R1, R2, R3. Okay, R0, R1, R2, R3. Then we find that R1 is homogeneous, R2 is homogeneous, and R3 is homogeneous. So we keep them as it is. Then we go to R0. R0 is not homogeneous, so we split it into 4 parts. R00, 01, 02, 03. This has to be 03. Okay. Now, one drawback of this split approach is that here you can observe that R02 is similar to R03. Okay, so this is your R02 and this is R03. And these two are similar, but still they are indicated as separate regions because every time we keep on splitting the image into four quadrants or four regions. So this is one drawback of a region splitting approach. Another drawback of region splitting is if regions are having very small sizes. In that case, if we start from the original image, we need many iterations or it is time consuming process. Okay, so this is one more example of region splitting. Okay, so we start with original image, we divide it into four regions 0, 1, 2, 3. Then 1 and 2 are uniform. So we go to R0 and R3, we split them further R0, R3. After splitting, we find that this 0, 0, 0, 1, 0, 2, 0, 3 are uniform. No further splitting is needed. So we at first split we get four components 0, 1, 2, 3. Then we apply second split for R0 and we get four components 0, 0, 0, 1, 0, 2, 0, 3. Then for R3 also we apply second split and we get four components 3, 0, 3, 1, 3, 2, 3, 3. Now after this we find that 3, 0, 3, 2, 3, 3 are homogeneous, but 3, 1 is not homogeneous. So we split it further and we get four components 3, 1, 0, 3, 1, 1, 3, 1, 2 and 3, 1, 3. And now they are homogeneous. So we stop the splitting process here. Again, in this image, if you look here, this region is similar to this portion, it is similar to this portion, it is similar to this portion, but still these are treated as different regions. This is your R1, this is R03, then this is 30, and this portion is 310. Okay, so this is drawback of splitting approach. So how to resolve this drawback we will study in the next lecture. Okay, so that's all for today. I request all of you to type your attendance.